As an operator, you may be responsible for the operation of many different types of heat exchangers, including condensers. So it's important for you to understand how they can be started up and shut down. To get an idea of the steps involved in starting up and shutting down a condenser, we'll watch an operator as he places a condenser in service and then takes it offline. The condenser we'll use in our example is part of a distillation process. It operates at a pressure well above atmospheric, and the cooling in the condenser is accomplished by water that passes through the tubes. Before starting up this condenser, the operator verifies that the valves on the condenser and its associated equipment are properly lined up according to his startup procedure. With the valve checks completed, the operator opens the vent valve on the tube side of the condenser. Then he partially opens the cooling water inlet valve. The sound of escaping air means that cooling water is filling the tube side of the condenser. When the tube side is filled, a stream of water flows from the vent. Then the operator closes the tube side vent valve. With the vent valve shut, the operator fully opens the cooling water inlet valve. The cooling water flow is controlled by the outlet valve, so the operator partially opens the cooling water outlet valve to a predetermined position to establish flow through the condenser. At this point, the control room is contacted and the process can be started. When the distillate reaches a predetermined level in the receiver, the distillate pump is started and the condenser startup is complete. Now, for a condenser that operates under a vacuum, the air ejectors would be started before the process fluid flow is started. This would remove the non-condensable gases from the condenser and create the initial vacuum. In addition to starting up a condenser, operators are also involved in taking condensers out of service. During a condenser shutdown, if the flow of cooling fluid is stopped before the process fluid flow, the condenser could overheat and be damaged. Once the process has been shut down, the condenser can be shut down for maintenance. The operator shuts down the condenser by closing the cooling water inlet valve and closing the cooling water outlet valve. Since the condenser is being shut down for maintenance, the tube side will need to be drained. That's done by opening the tube side vent valve and the tube side drain valve. Once the tube side is drained, the shutdown is complete. In some cases, it may be necessary to purge a condenser with an inert gas after shutdown. Purging removes vapors that could promote a fire when exposed to air. When a condenser is up and running, operators regularly monitor its performance. Keeping a close watch on condenser operation can help ensure that the condenser is working properly. Let's take a look at some of the routine checks that operators typically make in order to identify problems and ensure that a condenser operates safely and efficiently. One important check is the level in the receiver. This can be checked using a sight glass on the receiver or from a display or a chart recorder in the control room. If the receiver level is too high, the condenser shell could flood, reducing the condenser's efficiency. If the level in the receiver gets too low, equipment located downstream of the condenser could be damaged. For example, if the receiver level gets too low, the pump that's used to pump distillate out could cavitate. The cavitation could prevent the pump from operating properly and damage the pump. A controller on the receiver automatically maintains level. An abnormal level could be an indication of a problem with the controller. A low level could also be an indication of a problem with the cooling water flowing through the condenser. Another important operator check is the unit's temperatures and pressures. These indications can be checked on instruments attached to the condenser or on displays in the control room. One pressure reading that is important to check is the receiver's pressure. If the pressure in the receiver drops too low, the product liquid may flash back into a vapor. The condenser's pressure is also important to check. On condensers that operate under a vacuum, insufficient vacuum may affect the efficiency of the condenser. Too little vacuum can result from steam pressure being too low at the air ejectors, from air leaking into the condenser, from too little cooling water flow, or from the cooling water temperature being too high. Many condensers have control valves that regulate the unit's cooling water flow. An abnormal cooling water temperature could be an indication of a problem with the control system or with the cooling water system. Contamination in a condenser may be caused by a tube leak in the condenser. One way to check for contamination is to take a sample of the lower pressure fluid and test it for the presence of the higher pressure fluid. In some cases, contamination in the sample can be seen. In addition to sample test results, conductivity and pH readings of cooling water may indicate a tube leak. If there is any indication of contamination, it's important to determine the source of the problem and take the appropriate corrective action. In this part of the program, we looked at how condensers operate, and we examined some typical condenser startup and shutdown procedures. We also covered some of the basic checks that operators typically make on condensers. Now let's try some practice questions on this material.